Our Mstie unit, Moving to Mars, aimed to engage students in hands-on, inquiry-based learning and to involve students in questions central to current Mars exploration. This involved teaching engineering concepts and physical, earth and life sciences. It provided a context for learning about the environments and geological development of both Mars and Earth, which, in turn, brought about a connection with global warming and sustainability. Students were introduced to the different planets and vastness of our solar system and explore the range of tools scientists and astronomers have used throughout history to inform mankind's understanding of the solar system. They learned that getting to Mars is no easy feat and that fuel loads and payloads determine what can be taken to Mars. Finally, students explored and researched what it would take to live on Mars before building their own model Mars colony. Throughout the unit, students engaged in hands-on inquiry-based learning experiences to build understanding and lay the conceptual and experiential base for future learning. Activities were sequenced so students could progress from introductory experiences to more advanced investigations and deeper understandings. The questions that underlined our Mstie unit included: how do we engage student interest and ingenuity, inspire confidence and joy in their own reasoning abilities, teach without telling, help students develop habits of mind as they make meaning of Mars data, and structure investigations to ensure student ownership. We believe a scientifically literate society is built from exposure to carefully crafted lessons that reveal students' misconceptions and which engage them in activities to help them reconstruct their understandings. Engage. Lessons 1 and 2. Students were assessed on their prior knowledge of the solar system through the use of a TWLH chart, development of a wanderings wall, and participation in a Kahoots quiz. Students were also involved in an activity that introduced them to interplanetary distances. Broad questioning was used to encourage students to discuss their ideas and experiences throughout these lessons. Explore. Lessons 3 to 8. Students completed an infographic about a chosen planet, which served as an excellent introduction to the Star Lab incursion. Students were involved and engaged in the Star Lab presentation, which prompted a great deal of interest in black holes and the enormous sizes of known suns compared to our own. In exploring the atmosphere, magnetic field and geological features of Earth and Mars, students were involved in a range of activities and investigations. These included using a water balloon and lighter to explore Earth's atmosphere and global warming, and the construction and eruption of a volcano. Students also drew their own Martian that demonstrated their understanding of the environment of Mars. Another highlight for the students and for us was the opportunity to design an airbag system and land their own Egg Mars rover.
3, 2, 1! Yay!
While exploring space travel, students used recycled materials, balloons and rubber bands to make a landing system for their rover Egg before launching it from the top of a ladder. Explain. Lessons 9 and 10. Students developed and participated in an investigation into the effects of pay and fuel loads on space travel, using a balloon rocket and adding weights to their rocket and recording the effect. Students then used a graphic organiser to develop and collate information about the different structures that would be needed for a Mars colony. Also the materials that would be available to build them. This activity set the students up to successfully design and build their own Mars colony. Elaborate. Lessons 11 to 14. Students consolidated their developing knowledge of Mars and space travel by designing and building an element of a Mars colony. In pairs, students used recycled materials, glue and sticky tape to build a structure. Among these included hospitals, living quarters, laboratory, gym, train station and car dealership, complete with a Rolls-Royce rover. As part of their assessment, students were required to apply explanatory labels to their structure in order to justify their choices and demonstrate their scientific knowledge. Evaluate. Lessons 14 and 15. Students were required to develop and deliver an oral presentation about their structure to their classmates.
This structure is a car shop. It's important as you need a faster way to get around and explore. You wouldn't want to walk everywhere, would you? No. Can you give me a tour of your car shop? Sure.
After each presentation, the class had an opportunity to provide feedback and ask questions of the presenters. This made the pairs accountable for the information and science behind their structures. Students used their 15th and final lesson to reflect on their learning using group and individual reflection questions and a group rubric. The moment occurred during lesson 14 when the Mars colony structures from both classes were assembled and laid out on the floor. The colony brought together all of the science, knowledge and wonderings that the students had gained over the previous 3 weeks and combined it with their own creativity and imagination. It was the moment we could see all of our effort and hard work come together and that we had achieved what we had set out to do with the unit. The students really enjoyed the activity and the opportunity to apply their learning in a hands-on, meaningful and creative way. We were able to integrate all of the curricular links that we had planned except for civics and citizenship. This lesson was removed due to time constraints. Some of the key science, design and technology understandings that students took from our Mstie unit included the planets that make up our solar system, their order, composition and distance from the sun. That Earth has a magnetic field and an atmosphere that is made up of distinct layers, including the ozone layer. Mars may have once looked very similar to Earth and remains the only planet within our solar system capable of sustaining a human colony. The difficulties of interplanetary travel and of sending payloads into space. Our understanding of space and Mars has evolved due to rapid advances in technology. What it will take as an individual to travel to and live on Mars. What life support systems and sustainability problems will have to be solved before a successful Mars colony can be established. Our biggest limitation was time. To truly dive into the subjects of our solar system and building a colony on Mars would ideally take an entire term. On reflection, we would have given the Science Journal to the students in hard copy and not relied on Google Classroom. Only one of us had access as the students worked on it. In addition, only being able to see this document online made it difficult to keep track of what each student had completed. Overall, we thoroughly enjoyed our time at Newham Primary School teaching our Mstie unit.